Okay, so today I'm going to be walking through kind of regression models and how we can set up our code using cookiecutter data science, run some regression model tests on some Kaggle data. So first up, let me pull up the kind of Kaggle data set we'll be using. So I wanted to use a pretty basic sample set. So I looked at their playground, and this way we can kind of check our model against the leaderboard, as well as have pretty clean data where you shouldn't need too much feature engineering to get a decent score out of, because that's just Kaggle for you. So, or Kaggle, I think it's Kaggle. Someone let me know. So this is the data, and essentially it's for building creative feature engineering and checking out regression techniques, and we'll be doing both of these types. The data, we're giving a training set, a test set, a description, and then a format to submit our sample submissions, as well as I love it whenever they provide me with metadata and what I should expect in my columns, so that I don't have to do all of that lookup. But if I go to training CSV, they do kind of the simple exploratory analysis. So we do have NA values that need to be filled, among other things. So what I'm going to do is I've pulled up a Jupyter notebook. Well, actually I've pulled up a folder, my folder for this project inside of vscode. I'm going to open a terminal, and in that terminal I'm going to not use PowerShell. I'm going to go to command prompt, and I am going to use the cookiecutter data science structure to download and install kind of my file structure, so I don't have to do any of my file structure setup. So it's going to automatically spin up everything you see here, which we won't use all of it, but we're going to just spin it up so that I don't have to create the file structures, and it kind of gives me a standardized format for going forward without having to think too much about it as I build stuff out. So what we're going to do is starting a new project. I already have cookiecutter data science installed on my computer in my my Python notebook. And so if I click down here at the bottom and I click let's do Control-Shift-P, I'm going to select my Python interpreter, and I'm going to select my workspace, and I'm going to make sure I have the analytic space chosen because that's what I named mine. And it's going to make sure that all of the code is run in that space. It should pop here at the bottom. Let me try one more time to make sure it's selecting the right interpreter. In this workspace, analytics. Okay, so let's try that. Okay, yeah, it went to base, it went to analytics, so I'm in the right workspace. So now I'm just going to copy and paste my cookiecutter data science. So I don't want to re-download it. I want to I'm missing a... I'm going to pause. So we're just going to click yes. And I'm going to give it a project name, and we're going to call it Housing Prices. Housing Prices. And we're just going to click enter, enter. Give it an MIT license, it doesn't matter. Press enter, enter. I'm going to Python 3 interpreter. And there we go. Everything is now on my left. Cool. So next, we're going to go to models. Well, actually, we're going to go to notebooks, because models is where we save the model output. Notebooks is going to be where we open our notebooks and kind of put code there. So I'm going to create a new file, and we're going to call it, I'm going to start with random forest first. So I'm going to start with the random forest regressor. .ipython notebook. There we go. So that brings us to the first part. We're going to kind of import our standard packages. And what I mean by standard is, I don't know usually before I start a project if I'll use these packages or not, but I like them to be available to me so I don't have to import them later, and I can just keep coding based on what I'm used to. And those three really are going to be NumPy, Pandas, and something to plot with. And I use, Matplotlib probably more than anything else. And we're going to make sure that's installed. The next thing we're going to look at is we're going to have another cell. This is a cell, and we're going to import our training and test set. So here I'm going to have data. You have raw, process, interim, and external. So external, think about this as if you download data from like data.gov and you needed to land somewhere, you put that as external. Raw would be from like your databases if you set up a production environment, or like the housing data set, they're going to go here. And then process. So let's say I actually had to do a lot of transformations, like I have a notebook dedicated to EDA. I can save it all into into process, and then interim is like the what's in between, raw and process completely. It's going to be your interim. I don't always use interim, but I typically do use process if I need it. For our purposes, we're really not going to do any heavy feature engineering, so we won't really use any of the other three other than raw. So let me stop and get these files located into my raw folder. Alright, so as you can see here, we now have the data located in the right spots. And then all I'm going to do after that is I'm just going to display the data to make sure everything works fine. So let me make sure the right interpreter is running, and then we're just going to run those 3 lines. Okay, so we have a file not read error. That usually means that I'm looking in the wrong spot. Aha, so I misnamed this. And so we're just going to take out that R and try again. There we go, all loaded in. And head just is able to show us the top amounts of information. Now, I also like to ensure that code is structured correctly, because ideally you wouldn't run your code in a production environment from a notebook. You run it from a Python file that you can kind of set to a schedule. It executes the Python file, it launches it, runs all the stuff in Docker or whatever, and serves. So you wouldn't really do that in a notebook. Notebook is purely for exploring, kind of designing, etc. so forth. And we'll get to structuring Python files later. So with that in mind, I also kind of like being able to test out multiple different model types, and maybe even estimators and test rate. And so parameterizing things that can be standard across everything, you can just copy your notebook and change it if necessary, or we're going to look at a few different techniques to do stuff. I like to make sure that's possible. So the other thing I'm going to put at the top here is kind of my parameterizing where the models and the images that I'll export will go. That way it's all in one space. Now I'm going to kind of show you, multiple ways to do this. The first way is kind of what I did when my brain was just like, okay, we need to get this done. I kind of revert back to non-well-structured code or input methods, and that's fine. It'll get you, what you need. It'll likely get you employed fine, but really showing and standing out, you kind of need to stay up to date on capabilities and practices. So the first way I would do it is I would search through my code, and I would find all of those columns that have a lot of missing information that might need a fill, and I typically kind of label that. There's a better way to do this, so we're just going to leave that for now. And since I'm using a regressor and I'm not using a linear regression right now, I can kind of just fill in that information with -1. And this code, what we're doing is I'm creating a function because I need to run it across my training and my test set. And this is more of a validation set. Yeah, let's call it validation, because I'm going to split my train into train and test, and then I'm going to validate it in Kaggle, Alright, and upload those results. So let's run this again and get it saved under validation, and then this is going to be validation. Okay, so the first thing is I'm going to take in this file. I'm just going to create another version of itself. I'm just going to fill it with NA, and then with each column I am going to basically spit that back out. And so let's look at this line by line and see what happens if we just do it line by line. So let's get rid of this, back, and this, so we don't need to return anything. And again, when I built this, I just built a for loop and then I threw it in a function. I typically don't write my functions first. It's just how I learned how to do stuff. So we're going to just run train in here. And now run train head. If you notice, those NAs that were in the head are now all -1s. So what does factorize do? Let's go over here and we're going to say pandas factorize. Now, it encodes an object as an enumerated type or categorical variable. So it's a method for obtaining a numerical representation of an array when all that matters is identifying distinct values. So essentially, for the category columns, let's say I have an array and I have 0, 0, 1, 2, and 0. All of the zeros become B, 1 becomes A, and 2 becomes C. Is essentially what we're saying. And here, if I were to, factorize it, the codes, the stuff that comes out, 1, 1, 0, 2, 1, goes into codes, and the unique ones would be going into unique, as in what it means if I was, not wanting duplicates. Right, so they basically said if I had all of this, all my B's are 1, my A is 0, and my C's are 2s. So we need to do this because we're running a regression model. We're not running a classification model, so everything has to change from text into numbers. Now, the requirement for your regression model when it comes to this will vary by each model. I'm doing simple categorical encoding because it shouldn't matter so much for a random forest regressor. It will matter for things like a linear regressor because of how it works, and you will probably have to use, not probably, but you'll use one-hot encoding, and we'll talk about that later on. But essentially, if I were to run this line of code, and let's say I did train, let's say MS zoning, and we're just going to copy. All right. So now if I type unique, these are my unique zones, and then if I were to just relook at train.head, zoning now has specific numbers associated with each of these categories. So that's all I need to run a regression model. So I'm not really too fussed about EDA right now, simply because it is categorical data. I'm just going to get stuff running just based on what I know. And we'll see what comes out of it, and then we can start feature engineering after. That's just my workflow. Your workflow could be different, but this is just going to fill in that missing data. And again, there's better ways to do this, but this is the way we're going to do it now. The next thing we're going to sort of consider is we need to have our columns that are feature sets of our model, meaning that we want the model to use the information from those columns to predict a separate column. And the column we're predicting is typically your Y, and the other columns act as your X's. So, validation. So we want to predict the sales price. So we're going to drop that from our main database, and that's going to be our X values, and the sales price column alone will be our Y. And then I'm also just saving the validation set again for when I want to use it. So the next thing we're going to do is what's called a train test split. And this train test split will look different based on whatever you're working on. Typically speaking, the standard values are an 80-20 split. It's not always true based on the amount of actual values versus other values that the non-actual predicted value, like if you're doing with classes or things like that, or you need to sample or undersample, is not always this case. I have a completely different validation set, so I can do a whole validation run and check it on that set, but this is kind of the standard. And then, Hitchhiker's Guide to the Galaxy, so 42 is our random state, and it's just going to give us 80% of the data in X train and Y train, and then 20% into X test and Y test, and that's again not without the validation set. Without the validation set, so we won't need that. So I'm just going to run that column, and there we go. So now it's split, and what we need to do is basically fit our data to our regression model itself, as well as set the parameters. So again, I really do think it is good practice to really think through not having all of your code hard-coded in everywhere so that you don't have to do all the replacements. You could iterate over something like a list of parameters, or in this case a dictionary of parameters, and just iterate through it in a for loop, in a function, and you can test it a whole bunch of stuff. And all you have to do is change those values there one time, and you don't have to change it everywhere else in your code. And this, knowing this type of thing is what will really separate you from the pack, because it's often missed over in a lot of boot camps and academia as far as how do you structure code to run for success in a production environment and really getting to formatting. So I typically like to set up a parameters, and then what you can do is when you're running, you run like this. So here I am going to import a random forest regression model. So that means I now need to add my import statement to the top of this file. And there's going to be a lot of import statements. I don't want to import them all at one time. I want to be able to show you what they do. And so here, if I go to RandomForestRegressor, yep, in history, how do you read this? So this is a function, and this function has several methods that work on it, right? And so this is a random forest regressor. It takes in its function so it can run in the background code. These estimators, these criterions, these depths, these splits, and everything. When you change these things, that's called hyperparameter tuning, because you're changing the input values to hopefully improve your model output. Now, the attributes, so these are kind of your parameters, right? And your attributes are things that after you run it, you can call it using that. So that means if we go to the code, we'll see after I run this line of code, and so let's rerun that. And if I go down and I run it, I am then able to I didn't run all of the factorizing. Give me 1 second. We're going to run the columns that need to be factorized. We're going to, there we go. It's already been split, shouldn't need to split it again. Oh, yeah, actually we do because it wasn't factorized, right? Parameters, run regression model. Okay, so now if I take the variable which I saved my model to, I can call estimator, and it's going to give the estimator a decision tree regressor. That's all that means, is I can pull these at the end. And they each have a purpose based on the random forest algorithm. I believe all of the ones in scikit-learn are by like Leo Bayman, I think his name is. But essentially they turn these mathematical algorithms into code, and now all you have to really do is tune those parameters going into the code and then check the stuff coming out to make sure it works so that you can launch your model on the data set. And we'll get to add a bag score for random forest and these types of things separately. Yeah, Bayman is who this algorithm is built on. So we can check all that. And here, these are other methods, properties of it, which you can run on it as well. Any fit, get parameters, predict, score, set fit requests, or set parameters. And this is the one that I was using to basically run this dictionary in. So instead of having to, typically what you do if you're doing one by one is you'd put all of this in here, all of that in there, and instead I'm not doing that. I'm basically setting parameters here so that if I wanted to make more copies of these and throw this into a dictionary and a function, it would just run all of them, right? And then I'm fitting it to my training data. And I'm going to fit it to my testing data. That's the next part. We want to fit to our testing data. And so that's going to, predict on our testing. So we fit it to our training, and that's kind of the initial model training, really. And actually, we can look at the academic definition in the method. So You know, it's kind of hard to explain what you just understand. So it builds the tree. So in a random forest regressor, it basically takes a bunch of different decision trees, gets the output, and then averages that together. And that's what a random forest regressor do. We're going to look at XGBoost, and that does differently. It kind of trains on the previous tree to improve the outcome of it. So random forest really uses, I think, what's called a bagging method, and then like XGBoost and gradient boosting models use a boosting method. And you can, I think, yeah, you can use like a boosting on a random forest. They do have that sub package available. We're not doing a random forest booster right now. We're just doing a straight up random forest regressing bagging model. So it builds all of that, and then you're going to predict on your test set, because that's going to kind of, you're using your training data to predict on your test set to make sure everything is correct. And what does that look like? That is just going to be calling this predict function on the regressor that you just built. So we're going to get rid of this, and we predict on our text data, and we're going to call it Y predictions, because we're going to compare it to Y test. So we're checking this this X test, and we're going to predict what the Y values are, and we're going to check on it by comparing the output of the predicted values to the actual values of Y test. And that's how we know if our model is working right. And then we have kind of metrics that align with that. So what I really like about starting with kind of tree-based models, granted, everything isn't really, you're not really able to know how it makes all its decisions, but you can kind of get output for what features it thought was most important to solving the problem it had on hand. So here I have code for creating a plot. So the first thing is we really would like to know about the feature importance. That is a feature, again, reading the documentation. We know that we have, what area is it? Feature importance, feature names. No, that goes into the model. And all of these things mean something different. We're not going to get into all of that now. Where is it? I know it exists. And it might just be general under the decision tree. Or I might have to import it. I don't remember, I just know. Yeah, I think it's just a part of it. So as long as you have it imported, it's pulling from somewhere else, and we can actually check that. So if I go to feature importance, regressor feature importance, there we go. So it's a feature under, I missed it. I knew it was on there somewhere. You're just going to call that up, and it's just going to kind of tell you what it thinks was the most important for its predictions. So what we're going to do is we're going to create a plot in matplotlib, and the standard taxonomy for that is you have a fig, and you have an axis, and you have subplots, and you basically create a layout of a certain size, which is this area, and then keep it in that area. So I'm going to take my columns, and I'm going to take the sorted values from top to essentially the biggest ones at the top and the smallest importance at the bottom of feature importance. And then this is kind of how I'm naming my axis so I can know what everything is. And we're just going to print that out. And so here, the sales condition was the biggest predictor. And all the way down to, like, if you're looking at the top few or whatever, these would be the top few. And the least importance was going to be MS subclass, right? And it's just how important it is. They all have numerical values, and we can plot this several ways. I just like to see a nice handy bar chart. So what else is important? Typically what you'll want to do is you're going to want to save these pictures, and we'll do that as we do run multiple estimators at a time to show you how to do that. But we want to save this. We potentially have to present this in a PowerPoint. We might have to email these graphs. So having a way to just export and save it and upload it to where it needs to go is important. You might have to attach it to like a ticket. Like if you're doing like a in-house, like how do you solve this problem? Oh, this is what it should look like. Type of situations, you really want to be able to do that. The other thing is we would like to look at the error rate. So here, and I need to import prediction error display. And I'm going to need to import, I'm looking at, it needs to be absolute squared error. I never corrected that. Okay. And we're just going to import these at the top. Alright. So this is going to be absolute. Because that's what I'm looking at, a bunch of other ones that just works out better. You need to run it. And this should be y test. Oh, code from me running multiple at the same time. We don't need any of that. Okay, so we have an R squared of 88 and a mean squared area of 18,000. And if we look at the graph, I have tons of little outliers everywhere. It's not too bad. I mean, that's pretty good. I mean, and if you were to just run regressor.score, X on a train. So we want to import. So R squared, you don't have to import the R squared itself, but you can. It scores the same, or it should be the same. But let's say I wanted to look at the accuracy score, which is comparing both. It should be the same. That's going to be y test, y pred. I'm guessing it just has to be scored. It's going to be the same. Okay, so next I'm just going to copy this over into a new notebook. So copy paste. And we're just going to kind of refactor this code to include multiple parameters, as well as potentially a better, well, not a better kind of data pipeline. It really just depends on what you're trying to do. So here we've imported the data, and what I'm going to do is I'm going to add more parameters here. So essentially what I've done is I want to compare the R score of all of these, and I'm going to simply save them to a list so that I can call them. The next thing I'm going to do is essentially combine all of these into a function so that it can run and save to a file as it runs, so that I don't have to screenshot or do any of the shenanigans I did when I didn't realize I could save everything. So we're just going to copy that code over. So I have a parameter that I'm running through in an index because I just want for the naming convention of the files, I want to know the index. This is absolute squared error, and I'm doing that because I changed it in other code and I just want to use the same error. And we can do a whole lesson into which one you want to use. It's not going to be today. My brain has to process the math. But we basically just copied everything we just did into a function, and this prints out, runs that function. I don't really need to return anything. I'm just going to run that model and make sure I have the index to save. Now, we can also do a few other interesting things. So earlier I said, running this missing like that will work. For this case, you might have to impute features or do some other stuff. Now in scikit-learn, they have a whole thing called selectors and like column transformers and tree processors. And so it is a newer feature. Let's pull up, let's do selectors, column, make column select, go back, make column selector. And it's in this new compose. And it's a nifty feature because I can call these different things and run it on multiple different models at the same time. And it just, runs. You can do it without that as well. Like I could have used an ordinal. I'm gonna show you the encoders I'm gonna use, but I could use it instead of filling the NA stuff, and it will just process for me. So instead of doing it this way, I could have used an ordinal encoder. That would be this, and we can go look up what that does. Here for pre-processing. So here, if I call an ordinal encoder, it will just fit on the category data and run. So one thing that I really like about the, it makes my job easier. So like instead of having to hunt down all my categories, I can just do like this. And what we have is a category selector and a numerical selector. So it's going to pretty much include only those data types that are objects and only ones that are numbers in these two selectors for me. That way I don't have to shift through the data myself and figure out which ones are ordinal, which ones are not ordinal. Which ones are categorical and which ones, aren't, and then do basically make that whole column thing that you saw. I don't have to do that. Instead, I can simply let it do it for me. And so we're also going to go ahead and import the ordinal encoder. And we're going to rerun that here. Yep. Because this is a new, let me save. This is a new notebook. And so we're just going to run, and it selects the categories for me. And so previously you saw me do the fill in A. I can simply, let's go to the documentation and pull it up. So I can basically get an ordinal encoder and then fit my columns that are categorical to that ordinal encoder, and it'll work just fine. And I can set, my parameters to missing values, -1, and then you can run that through, which is essentially what this code is showing you. If you're doing it in a pipeline, then what you'd want to do is, select your columns and we're basically going to create what's called processors. And I'm going to call these tree processors because later on I have, what is it? Linear regression, and that's a linear processor. Now, I have to double check my Random Forest book, but I believe they actually have the automatic mean imputer in kind of the algorithm for the classification models or median. Some of those are kind of preset just depending on what packages you're using. I'm going to leave that in for now because it's just going to set it to the median across the entire data set if it's missing. So before I filled my missing values with all of it fit with -1, no matter if it was numerical or if it was categorical. And so now to make it actually better, I'm saying, hey, fit only my categorical with -1, unknown with -1 if it, not known, and then -2 is missing. And that's just pulled straight from documentation. It really doesn't matter what you set it to, not really. And then if it is a numerical column, then I just wanted the mean of the entire column as a better way to do it. And so then I'm going to just call make column transformer, and it's going to say, hey, if it's numerical, like use the numerical processor. If it's categorical, use the categorical processor. And that's pretty much that. Hold on, I need to run this up here. So simple imputer is there, and here we go. There. So next, we kind of now have our our trees and tables set up, and we can now kind of take off the cells, just like we did before. Y is your target, column the column you're predicting, and X includes everything else. Set up our splits on everything, and then essentially run just as we did before. Hold on. I think I need to edit some more code. Yeah, so it's in a pipeline now. So I actually need to edit this code to include the pipeline, and we're going to do that. So we need to make a pipeline, and that pipeline is going to run our code. So how does this work? What to do when your brain doesn't know what to do? Okay, there we go. We're just going to make a pipeline. So this is that code. So we're going to make a random forest pipeline. We're going to import our pipeline, and we'll go look at the documentation on making a pipeline after we import it, which I really like this feature, and I'm so glad they created it. So we can type make pipeline. Okay. So what does this do? It basically takes everything you just did and puts it in order and saves it to a dictionary that you can kind of pull the stuff from. Well, a tuple. We're not getting into data structures right now. I think it's a list of estimators. So chain together. You can do that. And so here, essentially, you run everything through it. And so in our case, we're saying, hey, our steps are going to be run the tree processor, then run the random forest regressor, and on it, and it's going to pretty much be what do we set parm, so basically here, and we'll fit it after. So we're just going to do that. That's going to get our pipeline. So that's going to get our up here. Okay. Now we're going to do this one by one so that you understand everything that I'm doing. All right. And we're just going to call this, we'll leave it as regressor. Okay. So if we were to do that, oh, yeah, run this. Oh, yeah, run it all the way to the top. No, actually, I think I'm going to do it this way. There we go. Yeah, so now it's running through all of them. It's just not going to print out anything. Yeah. So there we go. So now, in order to save these, we're going to do it like so. So we know that the previous code ran this information. We're going to do the same thing as this one. And we're just going to tab this over, and that should all be, well, actually it's going to break. I'll show you why it'll break, but it'll break. Yeah, see, it's going to break because I'm calling the pipeline and not an object in that pipeline. And so what do I mean by that? Here we have a regressor, right? I saved the pipeline to this. Hold on. Let's pull this all out so you can see it. And I'm going to call one parameter at a time. Okay. So we're going to just do this. We're going to do this. Underscore one. Okay. Now, this is a pipeline. Pipeline has no object attributes. Okay, so we're going to instead, pipelines, if we check the documentation, we have a pipeline. It has steps, it has memory, and it has verbose. So what we're going to do is I want to know my steps. My first step is a column transformer with these two things. My next one is a RandomForestRegressor. So I need to access it. If I say 0, what is it going to get me? It gives me the column transformer. If I say 1, which is the second value, it's going to give me the linear regressor. Now, if I want to say 1, 0, and let's say dot feature importance, what's going to happen? Well, this is just a string. It's not the actual regressor, so it should cause an error. I want the second one in that, and that should be able to give me a feature importance. Did I spell it right? Importances. That, yes, so it has no attribute. That's saying that attribute doesn't exist, but I know it exists, so I've got an S. And let me get rid of that extra dot. So these are my feature importances. So that means in order to get the output that I desire, I'm going to have to take this and put it here to get the right access. Okay, and this should theoretically run. If it doesn't, then I probably need to save it into a variable because it doesn't like that. What did I do? Cutting off stuff. Okay. mismatch shape. Yeah, so probably what I will do, that should not be train, that should be X test, and this should be Y test. Actually need to check that in my other code too. Did I leave it? Yeah, so this is wrong. This should be X. Well, actually, I guess it doesn't matter. It's just the columns. Yeah, okay, it didn't matter. It's just columns. Here, still a shape mismatch. Okay. This should be, I thought I changed it to test. See, losing my mind. This should be test. Parameters, index, mismatch shape buckets. Okay, give me 1 second. I think it needs to be saved into a separate variable to make it work how I want it to work. And we can check the lengths of these objects, because that also could be a thing. Okay, so let's save it differently, and I should still be able to print out. Here's my print statements, and we can graph that too. So let's just make sure these work fine, and I'm not missing anything else other than this mismatch feature set. Fit, okay, I need to predict, so that needs to be right, pred equals array dot predict x test. So if you look, it's all 97%. No matter what I changed here, we can make these worse. Made it worse. It kind of changed. Look at the third digit. Kind of changed. Didn't really change. But that's all. This is running it. And graphing it will make that much more clear, especially if there are significant differences. Now let's see if I can't get my feature importance out and saved properly. So what I'm going to do is I'm just going to check the length of my steps, and that gives me 83, but let's see what is x test. And I'm thinking it probably created additional columns. Not columns. It's 80. So I have 3 additional columns that were created. I wonder, and it probably has to do with doing it the ordinal way. It created an additional feature set. So I cannot use xtest to get my column values, and I cannot, if I look up feature importance, there are no column value names. And so what I am going to have to do is see if I can get feature names from this regressor. So let's go back to the regressor. Let's look at the criteria. So that's parameters. It has the numbers of features seen, feature importance, the number of estimators, base estimate, feature names. So names of features seen during fit. So if I take this, I might be able to get names out. So we're going to try that. So if I do, yep, so we have feature names. Let's see if we can get a length. don't think that's 83. That's 80. So why am I getting 83 when I do you know what, guys? I might not be able to graph this. You know what? We're going to do this in the not so fantastic way. And what we're going to do is we're going to say we're just going to eliminate the 3 hanging off. Yeah. And we're just going to also name these images. Yeah. So this is probably slightly inaccurate. But also I'm going to name these images. And so what we're going to get once I save, so these aren't saved. If you notice, I don't have a line for saving. Let me go pick up the line for saving. And this is index, and we're going to say refactored code, right? It's still going to save by name, and then I'm also going to get the prediction error display. And we're just going to say refactored here too. I'm going to change this to ytest. Alright, so I'm going to clear outputs, and I'm going to say run all, and we're going to hope nothing breaks. File not found. Okay, so I don't think reports, figures, so yeah, I forgot to create folders. So we're going to create folders. I like to organize everything. You don't have to separate your prediction error images from your feature importance images. I like to separate everything just so I can have a quick reference for whatever's needed. And that's in the wrong folder. Just want to move. Okay, so now if I run, okay. Don't need any of these, so those are all the images. Okay. So that's good to go. And good to go here. So, and remember, random forest regressors use boosting, not boosting, they use bagging, which is again averaging the output together from a bunch of different decision trees. And I really like starting with random forest because I can kind of dump almost anything into them and get something out. And the one thing you realize once you work on a lot of business problems is they just don't need as high of accuracy. It's not like a medical problem. And even with medical problems, you don't want to overtune your model and overfit everything. But, you know, even 80% accuracy can give a 2% business lift, which could be millions of dollars. So, you know, just depending on what your problem is and what your timeline is, you don't need to always, you know, go to the biggest, fanciest thing. Starting with this, random forests are great. They're a bit slow, which is why a lot of people opt for using XGBoost or LightGBM is the newer one out. That's winning all the, you know, competitions. And they're both boosting models, so they're going to kind of keep training on the same model from the previous weak predictor and get a better predictor out. And we can go into details in these models, but that's kind of not the, you know, entire point. So here we have all of the refactored images out. Here, let me save these out as well so that you can see them all go over there. And then we'll also save the model that we ran, because again, you typically, if you're using different, if you're using different types of software, they'll save the model for you, I think. Like there's probably a model save button, but all companies don't use the WYSIWYG model stuff, especially a lot of, depending on what type of team you're on, at what companies, right? They just don't use it. It's not beneficial to their ML product, and you are much more valuable if you can do some of this lifting yourself. Regardless of whether you're an ML engineer, you have a lot more negotiation. If you are slightly more what's called full stack, though I don't like that terminology because I'm not really an ML engineer. I understand the end-to-end process. I can get my stuff where it needs to go. ML engineers tend to steer more software engineering, especially bigger companies. And that's not my case, but I can get my code where it needs to be if I need to be in production real quickly. So it's more of an asset on a team, right? And so I'm just going to, see, I don't want refactored because it's not the refactored code. So we're just going to redo all of that. Okay. We're just going to delete these out. True cycle bin. We're going to move that out. Delete as well. Now, how do I save my model? This is a great question. You can pickle your model files, and the method you use to save your model is going to depend on what needs to open your model or access your model. I don't. Pretty sure it's just save _ model. You can pickle it. That's true. And pickle is just a Python specific file. Let me see. Save model. Huh. Pretty sure save model though. RandomForestRegressor. Let's see if it's listed there. Save. Okay. So we're just going to go with my gut. I have no idea where it's at. But here we predict. We're going to say regressor dot save _ model, and we're going to go into the model file. So that's / model. Oh, hold on. I'm pretty sure I imported that, so I wouldn't have to do it. Yep. So model directory. So that'll be model _dir / RandomForestRegressor. I'm going to save it as a JSON. Okay. And let's see if I'm right. Why does it not have attribute save model? Okay, we're going to find out. Let's do a Google search. Scikit-learn save model artifact. I guess I could just save as a pickle. But you should be, well, actually, maybe it's XGBoost that has save model. I guess if not, then I can just pickle it and load and unload my pickle file. I think that is such a funny name for a file format, you know. And pickling is just a standard Python package, actually. I don't know why I'm looking it up in scikit-learn. Pickle. So all you really have to do is dump it to a pickle file and load it from a pickle file. And so what we can do, I just want the code for it. I'm pretty sure you have pickle.dump, and then you have the data dump that you want, and then the output, right? And so I can come here, and this is pretty much the exact same code we're going to use. So I need to import pickle. Okay, and then my data dump is going to be my regressor, and then my output is going to be this, but I'm going to just use a pickle format at the end. A right attribute. Am I forgetting something when it comes to pickling? Yeah, I think you probably have to open the file to pickle. And then, okay. So this way. And we can copy that here. Because the file type, yeah, just like a text file in Python. Let's say output. Did that work? I might have to create the file. I don't think pickle dumps. Oops. I shouldn't have to create a file. Oh, you know what? This dot slash. Oh, it's a double slash if I do it that way. I don't. Okay, so let me remove this one. Actually, so there's not two things in my file. Still not. I feel so slow right now. It's been so long since I've pickled anything. I opened it. Dumped it out. I guess I'll just create the file. Python pickle module. But I don't think I should have to object file protocol imports. Yeah. I should just be able to dump my object. Okay. Let's. Okay, I'm going to go back one more time. So I saved that pickle file to an object. Okay, I'm just going to guess I'm going to have to create a file. There's going to be a line of code because I need to make sure for the pipeline that it so just need to snip it. Now the Python actual documentation, it is very annoying. Yeah, no, I can do that. But I do not have a data frame. with duh. That should fix it. Yeah, with statement. I was like, why is it not working? There's multiple ways to import, and there's a specific way to do it that does not require me to create a file. And dump output. Yeah. Call this output. And there we go. Out. So dump. Yeah, actually you'd want to add a date to it, the end of it, as a part of the naming convention, especially if I'm doing lots of models. Well, I'm going to pause and come. I forgot to put the F in front of the string. Okay, so instead of pickle, we're going to use job lib library, which is built into scikit-learn. And that might be causing errors because I haven't had to save my own models in a very long time. So let's try that way. Do this. I'm going to paste load dump. And then we're going to try this and see if that works better. And we're going to, and it could be because I'm doing it in the pipeline, which is newer to me. Loading right now. Yep, there we go. It's been, oh, it dumped already. Silly me. I don't know when it dumped. The pickle file did dump. Life is so hard. So there, that's it. So I'm just going to copy this and we're going to put it into the refactor code. And we're just going to say dump that model, and it's going to say refactored. Alright, and then here we're going to have the index value, and then we're just going to put this up here and run that. Alright, and then now this will also create tons of models there for us to basically load and start from that point. Awesome. So the next thing we're going to do is we're actually going to compare outputs from the regressor models of the Gradient Boost, the LightGBM, linear regression, etc., all in one file. And we can actually also look at them separate, but we're going to definitely look at them all in one file. Alright, so this is a notebook. I'm just going to create another notebook, and I'm going to just copy the refactor, and we're going to call it rename on comparison. And this code is pretty much straight from the documentation as well. I like to always check my documentation first, follow their kind of formatting, read through the methods, and go from there. I think it's very easy to try to fall into searching Stack Overflow and Google for stuff, but you'll become a better, I think, engineer if you're able to look at what's been done and kind of implement it and have that practice, and that's kind of how you grow, is because sometimes there's things in there and people haven't made videos on it. And so you're kind of going and looking at stuff that you don't need to quite yet when it's built in and you're pulling in packages, so you really have to learn to read it so that you can follow the updates now. Okay, so we're going to, actually I don't know, I'm going to pull up my notes. So we're going to essentially do the same thing we've been doing, which is make the pipeline. I'm going to get rid of these extra slashes up here. I'm going to save the code in. So this importing, this feature creation is the same. I am doing a linear regression, and so since I'm going to do a linear regression, I'm going to copy over my code for the numerical stuff for linear regression, and I'm going to need a one-hot encoder, which basically, linear regression, if you do the ordinal method, it will kind of think those are actual numbers, whereas if you do one-hot encoding, it kind of, I guess, vectorizes it so that that mistake doesn't happen, and it doesn't kind of tune to the numbers where it thinks it's actually a number versus a categorical designation. And so we're just going to import one-hot encoding into this file, as well as standard scalar, which helps us to stop making those problems. And we're going to just make sure that's analytics, which is where I created my environment. That is a completely different video. And so after that, we can essentially create pipelines for all of them. And we're just going to define the pipelines outside of a function, because it's going to have, we're going to use a stacking regressor. It's just going to stack them all together for us. And run that output. So the other things we need to import are going to be, and actually let me go ahead and put in some of this code here. There we go. So this is pretty much the code straight from the documentation, and we'll pull that up. And let's import XGBoost and our other LightGBM stuff. Let's move these up here, up here. So now all of this should be imported. Linear processor not defined. Pre-processors right there. Did I spell something wrong? Linear regression. Did I import my linear regression? I did not. Let's get that imported. And let's run this num selector. It's not defined. This column. Okay. I didn't any of this up here. Okay. I'm not gonna need, well actually I'll keep one. I'm not gonna need them all. I'm not running different parameters. And then let's see if that works. Not define LightGBM. Did I import? Let me add an import statement. That. Okay. And so I want these to be all the same. And so one, I'm gonna do dot set perms star param. Again, I won't have to change all these lines of code if I do it the way I have done it and just defined it here. And now I'm going to check the XGBoost documentation to find the exact same thing. It's probably the same name. I believe they try to stick by what does exist already. So let's look up, and I'm not using a random forest boosted model. I'm just using a boosted model. Boosting. Let's see. Set ram. Yep. So it looks like it's the exact same. And I'm thinking if this is the same, then it's probably the same for LightGBM 2. So let's just do copy, paste, paste, and let's see if that runs. Yep, same. So now I kind of create a list of all of my estimators, and I'm going to run it through a stacking regressor, and it's going to also run a ridge cross-validation on everything that I'm doing. And so we're also just going to delete this part out. This is basically how it'll run. You'll run your random forest and you'll get that out, the linear regression, the XGBoost model, and then the LightGBM model. And there's that lack of capitalization is going to bug me. Okay, so let me show you the documentation for stacking regressors. Combining predictors. So it's a method of blending estimators to see, you know, how they help each other or the differences between them. And at final linear regressor, the one that we're doing is kind of used to penalize it just a bit. And we're going to see if that improves performance. And also, I like the graph that it makes at the end. It's really nice. And so it walks you through importing their kind of data set so that you can see the R score of the different ones, and then the one where they're all stacked together. And if we do that for our model, I already imported this. Okay, and I'm going to import all my imports at the top. Okay. So what does this code do? It kind of zips the estimators together with the stacking estimator for plotting, because this is the plotting stuff. It gets the scores to all score them with the same score and get the R2 score out, which is coefficient of determination. Then we're just going to cross-validate those results. We're going to cross-validate the Y predictions, and then it's just going to display the actual versus the predicted for all of them. And this is just, again, setting all the parameters so you don't have to reset it over again, and setting the stuff that you're plotting against each other for displaying, and kind of get that out. So if you notice, this is kind of the random forest. It's not as tight together. The linear regression's tighter together. And kind of, because again, when you're looking at regression, it's the distance from the line, the point to the line, right? And so It could be overfit, it could be underfit. If you notice, linear regression is a lower predictor. The best one seems to be the XGBoost one, but not by much. These seem to be very similar, except for this has a lower error. So interesting. Honestly, any of them would do. And this is, you know, LightGBM versus these other two. Now, why would you want to use a random forest or these, you know, types of models? And we'll do random forest specifically, and then I'll probably have to make other videos to talk about the other models in more details, but really they're pretty much very similar. But a random forest is kind of what's called a non-parametric statistical model. And that means that it's really good at making statistical inferences regardless of the underlying distribution. So typically what you'll have is the ideal data set, which doesn't exist, is going to have a normal distribution. And a normal distribution is that bell curve image here. But oftentimes data doesn't look like that. It's going to be kind of wonky and all messed up. And so I like random forests, and why they're very useful to start out with, or starting with like a boosting model, is because it can take data where there's tons of outliers and get something out of it, which is why a lot of people use it. And it's a form, if you have, where's my big, oh, it's over there, my big Elements of Statistical Modeling book, but it's an ensemble model, and that means it takes a bunch of different models and it averages together. Whereas like your linear regression is just kind of running one model down all the way. But random forest, boosting, they use, random forest is like run a bunch of small weak learners and average them together, and then boosting is, okay, I have a weak learner, we're going to use that output to make another weak learner, and use the output to make another weak learner until it gets to the best desired output. These things are very good with data imbalances. Obviously they can be improved, like there's, again, tons of features we didn't talk about that are in the algorithm that we can use, but they're good with data imbalances. Random forest, I think if it's a regression model, will fill with the median value by default. You can fill it with the mean like I did, but it has things built in for you to be able to use it. For like, we're not going to talk about classification, we'll skip that in my notes. But you can also, no, that's also classification. So it's a good first pass. It's really good at reducing variance within the data. Don't have to do a lot of intensive data cleaning, in my opinion, especially on category data sets, just to get something out of it. You can do, like I like to do this part first and then go into more aggressive feature engineering and getting new insights out and coming up with new things. You can see the feature importance, which can help you reduce features, but also don't take that as like the standard. Just take it as, this is what it says now, but I think these other features might be important. Can I combine them? Can I scale them to make them potentially more valuable to the algorithm? Can I fill in any gaps to do that? And so you kind of have to think through those things, and that's a completely separate lesson. When we're talking about memory use, and this is important because, you know, how long it takes your model to train dictates how many runs you can do, how much it's going to cost the business. All of that matters for a data scientist. And having a computationally expensive model that doesn't really yield a lot of business output will make a lot of people very angry. And so random forests run on CPU times, and CPU is oftentimes cheaper than a GPU. However, XGBoost or LightGBM run on GPU, which is kind of like graphic processors, right? And they can oftentimes be faster. But again, if you don't have a lot of money and they don't mind time, then running a random forest that gets good enough on a CPU would work for your use case. You can, neural nets are similar. We didn't get into that. I didn't run like a TensorFlow neural net or PyTorch, or even just, you know, I didn't run into that. I don't think it's important for this lesson particularly, but you can do that, and you can see the comparison between the two types. I think that's pretty much everything you need to know. Oh, let's talk about real quickly before we get over kind of what we have now. And so what should we do next? You know, this references is for your PDF. So any PDFs of research that you find that you know, you can just ship this to your boss and they can just read your research of what you're doing, stuff I really like that. But this source code is really great. And the reason why is if I create a train model.py file, I can essentially copy and all of this here out into this file, and I can run it on Docker, and like it'll just execute the file in the YAML files that you create, or even not even just Docker, just it'll execute in the YAML file. And we're going to do this the easy way, and I'm going to export it as a Python script. All right, and so I did that, and where did it go? Where did it go? Untitled. Oh, there it is. Yeah, I don't want to save it. So just going to cut. We're going to delete that. You're going to train model. We're going to paste. And we're going to save. Now, this is not the correct format. You'd put things like this into a main function. And we'll talk about formatting your Python kind of file, executable files differently. You don't need any of these cell stuff that's automatically here because I ran in a cell. Just delete all that out. We don't want to run it like a we want to run it like a Python executable file. But typically, and I'm going to think about this off the top of my head. Typically, you'd have if main equal hold on. Defining main functions. Yep. If name equals main. Yep. There we go. And so your file would kind of look like this. And actually, let me export the refactored version because it has the, let's do this all over again. It has the functions in it, and that's kind of what I want. And so let's copy back from, I love the Real Python website. It is freely available and has everything I want on it. So you would, get rid of all this, paste it there. Get rid of all that, all that, all this, all this, that. You want to get rid of having to display anything, all that. So now pretty much all of this goes here. You leave this here. And indentation, hold on. Yeah. Yep, that's pretty much it. And you should be able to launch and run the code. The other thing you really want to think about, and why I like cookiecutter, is they start you off at least with where things should go and what you should have in a README. Your project should have a README. People should be able to come and help out with your code without being completely lost, and you can work on this as you go. I know of coworkers that really like making Word files and docs and writing summaries and step-by-steps there. You can do it there. You can do it here. It doesn't really matter where you do it. And so I like to, basically replace that with, where the code's from. I would, get rid of the files I don't need, and that would be these. I really don't need a make file. I don't need a license if it was internal. It tells where everything is. I'd write, hey, this file was for checking X, its output was Y, and this will be a whole nother lesson on that. And then you can actually load in the images as you write out your kind of summary of your results. But we'll do a whole different lesson on Markdown. This one's already way too long. All right, if you have questions, please follow me on LinkedIn, reach out, subscribe to this channel. If you're interested in doing the boot camps, I do one every month where we go topic by topic of some of these things so that after maybe a year and 6 months, you can transition into data science with a plan, really, and a look into kind of the types of this specific type of data science role, but you can kind of offload into, if you want to do data analytics or just data engineering, just offload at the point where you have all the topics that you need. But please feel free to reach out. I'd love to hear about your learning and all the different things you want to do and what you're trying to do and what you can use help with. I do a kind of data science book club where we go through papers and help you guys learn to read through papers and kind of discuss it in small groups as we grow. And you can find the sign up link for that newsletter below. It also is a book club, but it'll come out, I think, every week. And we'll kind of discuss in that. You can have useful information, news coming out, beginner stuff, and other opportunities and things you might want to know. With that, I'll talk to you soon.